Find the directional derivative of f is equal to xy plus yz plus zx at point p naught of 1 minus 1 2 in direction of vector u is equal to 3i plus 6j minus 2k. Now directional derivative of f is equal to gradient of f into unit vector of u. This is formula to find directional derivative of function f. Now we first find gradient vector of function f. They given that f is equal to xy plus yz plus zx. Now gradient vector of function f is equal to daba f by daba x, means partial differentiation of function f with respect to x into I plus daba f by daba y into j, means partial differentiation of function f with respect to y, plus daba f by daba z into k. Daba f by daba z means partial differentiation of function f with respect to z. Now partial differentiation of xy with respect to x becomes y, and partial differentiation of yz with respect to x becomes 0, because y and z are considered as a constant while partially differentiating this with respect to x, and partial differentiation of zx is z with respect to x. Now partial differentiation of function f with respect to x is y plus z into I plus partial differentiation of xy with respect to y is x, and partial differentiation of yz with respect to y is z, and partial differentiation of zx with respect to y becomes 0, because x and z are considered as a constant while partially differentiating function with respect to y. Now partial differentiation of function f with respect to y is x plus z into j, plus partial differentiation of xy with respect to z becomes 0, because they are considered as a constant while partially differentiating with respect to z. Now partial differentiation of yz with respect to z is y, and partial differentiation of zx with respect to z is x. So partial differentiation of whole function f with respect to z is y plus x into k. Now this is gradient vector of function f, y plus z into I plus x plus z into j plus y plus x into k. Now we find direct gradient vector of f in the point they given that p naught of 1 minus 1 2, that is gradient vector of function f in 1 minus 1 2 is equal to, we now put in the place of x 1 and in the place of y minus 1 and in the place of z 2. So in the place of y is minus 1 and in the place of z 2 into I, and in the place of x there is 1 and in the place of z there is 2 into j, plus in the place of y minus 1 plus in the place of x 1 into k. Now this is becomes I plus 3j. This is gradient vector of function f at point 1 minus 1 2. Now unit vector we should find. Unit vector is equal to vector divided by magnitude of its vector. Now vector u is they given that 3i plus 6j minus 2k. So it is, we can written as 3i plus 6j minus 2k. Now magnitude of u is square root of sum of squares of coefficients of I, j and k. So here 3 square plus 6 square plus minus 2 whole square. This is magnitude of vector u. Now this will become 3i plus 6j minus 2k. Now 3 square becomes 9 and 6 square become 36 and 2 square becomes 4. This is 9, 36 and 4. Now this is become, this sum is root of 49 and 3i plus 6j minus 2k. Now unit vector u is equal to root of 49 is 7 and 3i plus 6j minus 2k. Now we get both unit vector u and gradient vector f at point 1, minus 1, 2. Now directional derivative is gradient of f into u. Now gradient of f is I plus 3j into 3i plus 6j minus 2k divided by 7. This product is when I into 3i becomes 3, because dot product of I and I becomes 1. So I into j and I into k becomes 0 and j into I and j into k becomes 0. So dot product of 3j into 6j becomes 18, j into j becomes 1. So this 3 plus 18 by 7. Now this is 3 plus 18 is 21 by 7. So directional derivative is equal to 21 by 7 means 3. This is the final answer.